What's going on, guys? It's Bucky and welcome to your sixth tutorial in chemistry. And in this tutorial we're going to be talking about one of my favorite things. Woo, energy. Look at that. It looks mystifying. It's actually a pretty awesome topic. So anyways, I know before I said that energy is basically what little kids get when they drink Mountain Dew, but it does have a formal definition, and that is the ability to do work. So I know that you probably worked with a lot of people before, or maybe you know some people in school that do not have a lot of energy. That means that they do not have the ability to do work. And we all know people like that. But it gets a little bit more technical whenever we're talking about chemistry. So basically, energy comes in two main forms. I mean, it comes in a lot of different forms that you and me may be familiar with, like wind energy, solar, light, heat. We talk about electrical energy a lot, especially now that we're using computers and smartphones. But what chemists did is they kind of needed a way to classify it into two main groups. And energy is really hard when you think about it to classify because, unlike matter, it has a totally different set of properties. You can't see energy a lot of the time. You can't feel it. You can't pick up energy and say, okay, this is what it is. So they needed kind of a weird system to classify it. So what they did is they put it in two main categories, that being kinetic and potential. Okay, this is kind of getting weird now. I know what solar energy is and electrical energy, but what the heck is kinetic and potential? I heard of potential before, but what the heck? Okay, let me go ahead and explain. First, let me go ahead and explain kinetic energy, the main, I don't want to say the main category, but it's the more interesting category. I'll give it that. Kinetic energy is defined as energy of motion. Okay, go on. An example of this would be like throwing a rock at your brother. The harder you throw that rock and the faster that rock is going, the more energy that rock is going to have. So basically, whenever you have something that's moving, it's going to have kinetic energy. So just remember that. Whenever things are moving, they have kinetic energy. Now, a couple cool rules that we may want to remember. First, kinetic energy can be transferred from one particle to another. What does this mean? Let me give you an example. Instead of talking about little particles and atoms, let me go ahead and give you a big example. Say you had a baseball in your hand and there's a glass bottle sitting on the sidewalk. If you took that baseball and you whipped it at the glass bottle, as soon as it hit that bottle, the kinetic energy or the moving energy is going to be transferred from the ball to the bottle, and that is why that bottle is either gonna move a little bit if you just threw it softly, or it's gonna shatter if you threw that ball really hard, because the energy from the baseball is gonna be transferred to that bottle, causing the bottle to move in one of two different ways, either shatter or just, roll around a little bit. So all that depends on how hard you throw that baseball, how much energy is in that baseball. Now this last little thing says can also be converted into other types of energy. So we can take kinetic energy and it can be transferred into other types. For example, if we have kinetic energy like wind energy, we can make windmills and wind turbines and convert that, the wind energy, to electrical energy. Same things if you live next to a dam, or if you ever saw a hydroelectric generator, then they pretty much take the moving water, the kinetic energy from the water or river, and transfer it into electrical energy. So basically, through kinetic energy, we can convert one form of energy to another. Pretty cool. What we're most interested in is usually converting it to electrical energy because, electrical energy is pretty cool. You can use it for stuff like looking at YouTube videos, going to thenewboston.com, going to justin.tv/thenewboston. That's pretty much all you would use it for. I can't think of anything else at the moment, but that's pretty much what everyone in the world is working towards, going to my awesome website. So anyways, you're saying, okay, kinetic energy is energy in motion. I understand that. Why is there even another kind of energy? It doesn't make sense. Well, let me go ahead and explain that. Potential energy is the different side of the coin. It's stored energy. Whenever you have potential energy, let me go ahead and give you an example. If you have a bullet, there is a lot of energy in that bullet before you fire it. Of course, we know there's a lot of energy as it's going through the air and, before it hits a deer or a person or whatever the heck you're shooting at. But before you fire it and you have that bullet in your hand, there's a lot of energy in there. It just hasn't been converted into kinetic energy yet. So we call this energy that hasn't yet been converted into the kinetic energy potential energy. It's pretty much the potential to become kinetic energy. So another thing is that you may be a little bit more familiar with this, hopefully not too familiar, but your body also utilizes potential energy. Whenever you eat food, you store that energy in your body, which is in the form of fat. You know, you may be more familiar with that. It stores it in different ways, but mostly fat. And that way, we don't have to eat constantly. We can store that energy in our body, and whenever our body needs energy to do its different stuff, we can just go ahead and use that fat. And some people are really, really good at storing potential energy, if you know what I mean. So, to sum it up, well, I don't want to sum it up, is I forgot I have to talk about temperature. So, temperature is one of the ways that we can measure the kinetic energy of air particles. I know you can't see this, but there are a bunch of tiny little atoms in the air. There's like oxygen, nitrogen, hopefully two, some helium maybe, hopefully not too many harmful ones, but there's a bunch of oxygen, let's just say. And those oxygen particles are moving around, zipping around the air really fast. They have a lot of kinetic energy. And the faster they move, the more kinetic energy they have. So therefore, the higher the temperature. So we're going to talk about temperature later on, but I just wanted to touch on that now because temperature, whenever you're saying, okay, how hot is it outside? That's how you usually think of temperature. But what you're actually doing is you're measuring the kinetic energy of the particles in the air. Pretty crazy, huh? So, anyways, that's basically all there is to cover with energy for now. Again, there's a lot more concerning temperature and heat and energy, joules, calories. We're going to be talking about all that stuff later on. But for now, that's all you guys get. So, thank you guys for watching, and just remember, energy and matter are the two things that make up the universe. Matter is the stuff you can hold and feel, and energy is the stuff, the power, the force. You can't see it, you can't pick it up and hold it in your hands, but it's there. I mean, I guess probably if you took some drugs, maybe some magical mystical mushrooms or some acid, then you can probably see it. But most of us, we can't. We can't. So we're stuck with this makeshift diagram. So anyways, thank you guys for watching. Don't forget to subscribe, and I will see you guys in the next lesson.